Teach me about the Great Lakes. Teach me about the Great Lakes. Welcome back to Teach Me About the Great Lakes, a twice monthly podcast in which I, a Great Lakes novice, ask people who are smarter and harder working than I am to teach me all about the Great Lakes. My name is Stuart Carlton, and I work with Illinois, Indiana Sea Grant, and I know a lot about how to ruin years of equity by completely screwing up a podcast release schedule. But I don't know a lot about the Great Lakes, and that's the point of this here program. I'm joined today by the one, the only, the special. It's Carolyn Foley, Full Dog. How are you?
I am doing well, thanks, Stuart.
Fantastic. I'm glad to hear it. We're going to jump right in since we still don't have a beginning segment. Hey, if you have a beginning segment idea.
We don't need a beginning segment. We need to, you're right, that we can get faster to the interview. But first we have
an important update. This is from the Teach Me About the Great Lakes Hermit Crab Correspondent, Hope Charters. She sends in this video, and you'll need to go to teachmeaboutthegreatlakes.com/85 to see it, or you will need to look in your show notes on your podcast player. Now, normally my move is to just keep running with the inside joke and alienate anybody who didn't happen to listen. If you want the history of this, you want to go to teachmeaboutthegreatlakes.com/81 and listen to our interview with the wonderful Dr. Katie Stamler. This was live from my Egler, and Hope brought us some interesting facts about different types of shellfish and whether or not they change out their shells. And we had a fascinating conversation on that. And then we did a little bit of follow-up in episode 82. Which I'm just realizing now I wrote Stuart and Carlton speak with Meredith Brown in the show description. That was Stuart and Carolyn. We spoke with Meredith Brown, and we had an important update on different types of shells and which ones switch out or whatever.
That interview was probably more interesting than the important update on shells. But go ahead with your...
Yeah, no, that's fine. Those were both really great interviews. I mean, you should listen to those both if you haven't. But the point is this. Now we have this YouTube video. Carolyn, there's a hermit crab, but it does not have a regular shell, does it?
I mean, hermit crabs will use anything as a shell, and this is a fantastic example of them. It's a plastic doll head. It's a
plastic doll head.
Wonderful. It's
wonderful / terrifying. Like it is, and you look at the comments, some people are like, wow, what resilience. Other people are like, oh my God, plastic pollution. And I think the answer to both of those is, yep. So yeah, this is nightmare fuel, to tell you the truth, looking at it. Like it's this, and this is not a small hermit crab. This is a large hermit crab in a large doll's head. It's not quite Chucky type. There's no hair, but it's bald, and its neck is severed from its body.
Well, the hermit crab is the hair.
The hermit crab has the hair.
The hermit crab is
it is the hair. I was like, hermit crabs don't have hair. Do we need a separate mammal segment follow-up?
No,
right?
no. Let it. No, this is awesome.
But it's got like an Adam Duritz style fake dreads haircut. Yeah.
Yeah, that's awesome.
Anyway, so I recommend you check that out. That is our important hermit crab update. If we have one more, I have to write a theme song. So any other hermit crab news, send it in, and I will get right on the theme song.
There are no hermit crabs in the Great Lakes, but that's all right.
There are no hermit crabs in the Great Lakes. That is true. But there are many invertebrates, so we spent many times talking about. But the thing is, yes, this is a show about the Great Lakes, but it's also a show about hermit crabs and things that switch shells, which snails do not. But hermit crabs do. Fantastic. Well, with that, now foot graphic for something entirely different. We have an exciting interview about a science paper today and an important Great Lakes relevant topic, unlike, say, hermit crabs. And so we're super excited. But first, of course, we will transition with, I don't know, I'll just pick one. Fantastic. Our guest today is Daniele Miranda. She's a research assistant professor in the Stream and Wetland Ecology Lab at the University of Notre Dame. And she's the lead author of a new paper out in a very cool named journal, Science of the Total Environment. One of the best names for a journal. Not a partial environment, the entire thing, every bit of the environment. And this paper is called Occurrence and Biomagnification of, oh boy, perfluoroalkyl substances, or PFAS, in Lake Michigan fishes. Danielle, thank you for coming on. How are you today? How are things in whatever the name is, South Bend, Indiana?
Yeah, thank you so much for having me here.
So let's start with the basics, because we talk about PFAS a lot, and I do the episode, and then I instantly forget all about PFAS. And we like to scaffold up for all of our viewers. Like, we have experts on PFAS listening right now, and we have people who know nothing about it. In fact, we have all of those on this call. So let's start at the bottom of the scaffolding. So PFAS is, of course, a perfluoroalkyl how do you pronounce it? And what is it basically?
PFAS is the acronym for actually per and polyfluoroalkyl substances, but in this paper we're calling only perfluoroalkyl substances because we are only looking for those type of compounds. PFAS is this group of more than 10,000 man-made compounds that are primarily composed of carbon and fluorine.
So they're man-made, meaning so these aren't, these don't occur naturally. Where do they come from, PFAS?
They are synthesized, and we can find them in different day-by-day applications. For example, they are present in firefighting foams that we use them to extinguish fire, and also in non-stick cookware as oil repellent. But they are also present in food packagings and also in cosmetics. So we are in contact with them every day.
So they're kind of everywhere. This is interesting because this is what always confused me. Because whenever you read about PFAS, they talk about firefighting stuff, and I'm like, how much firefighting are we doing? That's it's like I've never fought a fire, and so these things are everywhere. Knock on wood, and but so it's a lot of other things too, including food packaging, which is kind of a rough thing for them to be in.
Coming back to these firefighting foams, we have training. We train the military. How do you call that? Military training stations. Yeah. So in military training stations, they use the firefighting foams to train it. Basically, not every day, but often. And then the foam is with the runoff goes to water and contaminate water base. And going to the food packaging, you can find it in several areas. I'll give this example of popcorn, microwave popcorn, and also fries. So having that plastic layer in the fries to avoid our fingers to get sticky with oil. So they put the PFAS in this layer as well.
I'm not even kidding. That's like my entire diet is microwave popcorn.
But you can microwave popcorn in just a regular brown paper bag.
Brown paper, yeah. Mm-hmm.
Yeah. So that's it. But yeah. So, and there are some places where they have, I think on the East Coast, because the military installations is where they first kind of found the big, like kind of hot spots, right? And then there are some places that have actually legislated that they now practice with foams that don't contain the PFAS.
Yeah.
But PFAS is still in all these other things that are around us all the time.
Mm-hmm.
Oh, interesting. So how do they get into the food web?
So with those, using them in our everyday products, they end up in wastewater treatment plants. They end up in landfills. So with that, they go to the, talking here about aquatic ecosystem, the wastewater treatment plants end up in water bodies, and then the organisms, they can be exposed. And we also have actually atmospheric deposition. So the individuals, they can be exposed through the exchanging gas, through the respiration, and also ingesting water, contaminated water, and also eating other animals that are contaminated with PFAS.
So why is that a problem? Why should we care that it's everywhere and getting into the food web and things like that?
Yeah. We should care because there are many peer-reviewed studies saying that those compounds can be related to deleterious effects to the human and the animals, wildlife health. For example, they have been associated with cancer, several types of cancers in humans, low birth weight, and also immune system, depletion in immune system responses, and also depletion in response to vaccines. So I don't think we want them around.
So then the PFAS story, if I can summarize for those of us who don't know, is like they're not just in flame retardants, they're also in like food packaging, cosmetics, probably not the cosmetics I use, and French fries, and we know they're in your cat. And maybe not your cat, but our cat. And so what they do is they have a lot, and they get everywhere. They go into wastewater treatment and all sorts of things. And then they get into the environment where they get into the different animals out there. And they can cause low birth weight, cancers, just all these deleterious effects. And we're just getting started. And these things don't go anywhere, right? They call them forever chemicals. And so they seem to stay in the environment once they're there.
Yeah, we have, as I said, like thousands and thousands of compounds, and actually we are only studying like I would say around 50, and for those 50 we already have results and studies showing their toxicity.
So then with that terrifying background, you decided to study PFAS in Lake Michigan fish, right? Or fishes. For those who don't know, ichthyology types tend to refer to fish of a single species as fish and fish of multiple species as fishes. So you look at fishes in Lake Michigan, right? That's what you wanted to do. So how did you study this exactly? What was your approach?
So for this study, we studied 9 fish species in between prey and predator, and we worked in collaboration with USGS and the US Fish and Wildlife, and this work was supported by Illinois Indiana Sea Grant and also USGS. And so for this study, we, with the help of USGS and the US Fish and Wildlife, we collected around 208 fish for this specific study, and in different areas of the Lake Michigan to check on the PFAS concentrations.
And so how did you look for PFAS in them? What was I saw you did stable isotope analysis.
Yes.
Now, I don't know what that is. In fact, I don't even know what an isotope is. So again, we'll scaffold up for idiots like me. The only isotopes I know are the Springfield isotopes. So what is an isotope exactly?
So in this study, we used 2 different isotopes, nitrogen and carbon. The stable isotope, nitrogen stable isotope, were used to look at trophic position, so we can use them for that. And with that, we saw, and then also to see predator-prey relationship. And for carbon stable isotope, we were looking to the different food sources. So with them grouping the nitrogen and the carbon stable isotopes, we could see which animals were related to each. So we could see, as we were looking to the biomagnification of those compounds, or how those compounds increase in concentration with the food web, we needed first to check their trophic position and their relationship with each other.
So the isotopes were more for drawing the food web, and
yeah.
And so it's like the relative amount of different types of carbon. So a stable isotope is one that doesn't. That's okay. This one I can actually answer.
Hey.
Yeah.
There's a lot that I can't.
It's like we always answer that. So I'm always like, my mind's like focused on the biomagnification answer.
Okay. So you look at the relative amounts of these different things to figure out.
Right. So there's some isotopes that are not stable, that like they have some extra neutrons in there. It's neutrons, right? Yeah, that they have in their nucleus, and they break down over time. And those are like the radioactive isotopes. But then there are stable isotopes that are like, they have like one extra neutron. Like, so a nitrogen normally has 14 things in its nucleus, but there is some nitrogen that has 15 things in its nucleus, and it'll live half-life.
You just know this?
Yeah. Well, yeah. I do have a life as a researcher as well. So yeah, and then they like, so in the organisms, you can look at kind of like the ratio of these two, and that tells you about the things that Dr. Miranda was saying, that like where they are in the food web, what food sources are they relying on, and you can like draw these cool patterns together. But then you also actually analyze the tissue for their PFAS concentrations, right?
Yeah. So first we were looking at the stable isotopes to see the predator-prey relationships and how they feed in the Lake Michigan, where and how they were feeding in the Lake Michigan. And then we looked at the PFAS concentration to see which of those compounds were bioaccumulating in the organisms and also biomagnifying in the food chain.
So bioaccumulating, I think I got these, but let me see. So bioaccumulating means which organisms are taking them up. But then once you move up the food chain, like a salmon, what does a salmon eat, Carolyn? Little baby, probably
smaller fish.
smaller fish.
Smaller.
And so a salmon eats a whole bunch of smaller fish, right? And sorry, Thomas. And so the salmon goes around cruising, and since it eats so many smaller fish, it accumulates a lot of these PFAS, and that's biomagnification. Is that right?
Yeah.
Within salmon, you would expect to see more PFAS than you would within these smaller salmon prey fish that they eat.
Yeah. Following with because some of those PFAS are persistent or classified as persistent organic pollutant. So following this idea that all of those compounds, they biomagnify or increase concentrations with the food web. So we would expect to see that happening. All salmonids with higher PFAS concentrations than prey fish. But then we had this surprise that generally speaking, all salmonids, they had those higher concentrations than prey fish. But when we look to sculpins, they had one order of magnitude higher concentration than salmonids. So you're like,
really?
Yeah. What's happening here? Maybe they are not, those salmonids are not preying they were not preying those sculpins, but how are they being exposed to those super high concentrations? So this is something that we have some hypotheses in this paper, but it's still not very clear to us.
So you were surprised that sculpins were so high and that wasn't reflected in salmon.
Yeah.
So there's a really cool, your graphical abstract is awesome. Like most of the time I'm like, so we'll put that in the show notes at the, what is it to me about the Great Lakes
/85 episodes.
Holy cow. But yeah, this is so cool and weird.
Oh yeah, there's like a whole break in the line here. Oh my goodness.
Yeah, like it gets from like 40 to 200 and for slimy sculpins. And like even deep water sculpins, but then gobies, which a lot of people have been worried about them like competing, they're like way low.
Nothing in the gobies, so that I just want to point that out. We'll put a pin in that. The gobies seem very healthy, at least in terms of PFAS.
Looking at this, I'm also looking at the graphic abstract here. We can see we associated those concentrations to where they live and also what they eat. For example, round goby, we collected large round gobs that it feeds more on dracaenids and more in dracaenids and live in rock environment. And when you go to the sculpins, they live in deeper environments and close to the sediment, and they prey on microcrustaceans. And some studies in other Great Lakes and other Great Lake in the Lake Ontario also saw the same pattern for sculpin and the Lake Huron for deep water sculpin, same pattern for the slimy sculpin in Lake Ontario and deep water sculpin in Lake Huron, where they had higher concentrations than their salmonids. And they were also associating to these microcrustacean that are microcrustacean feed habit, and also to be living close to the sediment, be exposed to the concentration of PFAS in the sediment.
And so do you all, I know this is all hypothesis, but do you think that the PFAS are kind of like just making their way out to the deeper waters and just like absorbing onto the type of bottom, like whatever's out there, like the mud or the silt or things like that?
Yeah, we have this class of PFAS, the big class with 10,000 compounds that share characteristics. But then when you go to the small classes like these 21 compounds that we were looking at, some of them are more, you can find more of them in the water and some of them more in the sediment. So yes, sediment is a sink for some of the compounds and more for the heavier compounds that is they are what we found in those fish. So probably the sediment is acting as a sink for those compounds.
But then there's other PFAS that are still in the water and still in the air.
Yes, yeah. Some of them are going to be partitioned to water, to the, as I said, to the atmospheric, to the air, and some to the sediment.
What gets you most excited about this research? Like when you're doing it, right? Because presumably you're a big nerd for this stuff. I mean that in a positive way, right? And so when you're in this project, what gets you excited, like with these data or next steps or whatever?
I love when I can put the puzzle together and understand more about those compounds that are in our day-by-days and how the environment process drive those contaminants, why we are finding those compounds more in one species than in other species, why we find more compounds in deep waters or in sediment than in water. So I love understanding that and putting this puzzle together.
So what are some next steps, like the next questions that you would like to ask or explore or are exploring right now?
So something that I didn't mention yet. So we had those salmonids with, we were analyzing only muscle for these species. And now we want to see more in PFAS in other tissues, and also some paper that was published in my group showed that PFAS can concentrate more. Some PFAS can be concentrated more in eggs, in salmonid eggs. Now we want to understand salmonids offloading, salmonid spawning can be transferring those compounds from big lakes to the streams here in Lake Michigan. This is one of the questions.
That is a really cool question to ask, and that one is more like, oh, like I'm on my face. They're like, oh no, that's creepy. Oh man, that's really cool. This is really cool work. Thanks for doing it. It's really cool.
Thank you very much.
Yeah, no, it's fascinating to hear about and to come on and learn about, from the very basics of what are PFAS and isotopes all the way up to this really cutting edge work that you're doing, finding out how totally hosed we may be. But that's actually not why we invited you here on Teach Me About the Great Lakes this week. The reason that we invited you on Teach Me About the Great Lakes is to ask two questions. And the first one is this. If you could choose to have a great donut for breakfast or a great sandwich for lunch, which one would you choose?
This is a very good question, but I'll say I'm going for the sandwich lunch because I don't like sweets in my breakfast.
Don't like sweets in your breakfast.
Yeah, it's a limitation that I have. I'm sorry. And the answer for the sandwich is also weird, but it's my preferred. It's tofu and avocado.
Tofu and avocado? That sounds wonderful.
Yes. Okay.
Do you make that, or is there a place to get it?
I make it.
You make it. So when I'm up in, I'm going to come up to South Bend to visit Tom Coombs. Teach Me About the Great Lakes weather correspondent. And nice. I'm going to go to his house on the first day and get a BLT with tomatoes from his garden. And that'll be nice. And then I'll go do whatever you do in South Bend. I'll hold up my arms like this at the football field. I will, whatever else you do. And then on day 2, I will come over to your house for lunch and we will have tofu and avocado sandwiches. And that just sounds fantastic.
And I like the tomato addition. We can also add tomatoes.
Perfect. This is the time of year for it.
Like coming up. Bread?
Yeah, toasted bread.
Honestly,
we're starting to get somewhere.
No, it's kind of funny. Like I really enjoy when people pick sandwich and they say, you know what, just come to my house and I'll make you a great sandwich.
That's the move. No, those are the best sandwiches. I completely agree. And so super. I won't bring up tomatoes this year because something is eating half of every tomato in my garden. I don't know what it is, but like I come out in the morning, I think it's a raccoon, and there's like just half a tomato still hanging on the vine like this, and everything else is completely, the other half is gone, and there's little ants on it. And I don't know what this little goofball is, but so I can't bring tomatoes this year, but hopefully Coombs will have them. Fantastic. Carolyn, do you want to...
Right. So our second question that we'd like to ask you is, what is a special place in the Great Lakes that you'd like to share with our audience, and what makes it special for you?
So I don't know much about the Great Lakes yet. I'm not from here, so I know a lot about south of Lake Michigan, and I would say the dunes. It's such an incredible place, and just go there and spend some time and watching the sunset. We can see the sunset from there. So it's some place that is in my heart.
I have a soft spot for those dunes as well. It's like, it's my husband and I used to like, because he's from Northwest Indiana. So when we were dating, we would go like in the winter and go see the shelf ice and stuff like that. So yeah, it's a nice.
Fantastic. Dr. Daniele Miranda, research assistant professor in the Stream and Wetland Ecology Lab at the University of Notre Dame. Thank you so much for coming on and teaching us all about the Great Lakes.
Thank you so much for the invitation.
That was a fascinating interview. I do have to point out, one of the things that we always discuss is how I can't actually record and think at the same time. Dr. Fish, Titus Seilheimer, Dr. Fish, Katie O'Reilly, and Teach Me About the Great Lakes Hall of Famer Brian Roth would all be very upset if we didn't mention that, of course, salmon eat alewife is the big prey item for salmon in the Great Lakes. So instant feedback there. Save your emails. Save your hotline messages, save everything else. And we'll bring that up actually with Dr. Fish next month when we record our next Ask Dr. Fish Live, which allows me to plug our next Ask Dr. Fish Live, which is going to be, when is it, Carolyn? Is it August 14th? August 14th. Go to askdrfish.com for info.
And then you also wanted to remind people about the newsletter?
Oh, I failed to do that in advance, didn't I? Yes, we have a newsletter, and I'm trying to actually get issues, I almost called them episodes, of it released with each episode of the podcast. You should go to teachmeaboutthegreatlakes.substack.com, sign up for our newsletter, have little behind-the-scenes info, a place to comment in case you don't want to be commenting on certain social media places as much as you used to want it to be for whatever reason. And so, yeah, you should go to teachmeaboutthegreatlakes.substack.com, sign up. It's free. It's a free newsletter there, and it's super fun. And I'm going to continue to release them more regularly than I have in the past. Thank you for reminding me of that. Speaking of reminding me of something you learned about the Great Lakes today, Carolyn Foley.
I don't know. I think it's just really, really cool / terrifying that these are chemicals that, they've been around for a while, but it's just sort of come to light that they are problematic and like really problematic, and that they don't necessarily follow the same type of thing where like salmon are the one who have the most. The big salmon, they're the top predators. They don't have the most.
Right, like with mercury, that's what you would expect 100% of the time, right? And that's why,
a bunch of other contaminants too kind of follow that same pattern where it goes up to the top predator. And so I think this is just a really, really neat area of research where people are trying to figure out how these chemicals that are super problematic, how they're moving through the food web, and is it just an exposure thing, or does it have to do with like what they sequester to their tissues? I just think it's really, really fascinating. So, and I really genuinely love like their graphical abstract. I was just like, oh man, that tells such a good story. Just really.
Yeah, that is the story right there, and they did a nice job. And usually graphical abstracts are kind of stupid. Or just like, oh, look, here's a graphical, it's like the highlight points that people do a lot of times. And it's like clearly not the interest of the because, scientists are scientists, right? And this is what they want to get as a publication. And but this one is very, very solid. Although, is it to scale? Is a sculpin that big? We should ask.
No, it's not to scale. Sculpins are pretty,
that's what I thought.
I think, anyway. I don't know. I could be wrong. I should note I'm not a great fish person. The sculpin is like a little bit bigger than the goby, and it's about the same time as the alewife, so that probably makes sense. But
anyway, this is another great question for our doctor's fish. So we'll be sure to bring these up next month. Why are we just speculating when we could bring in the experts? That sounds fantastic. And I know you're about to ask. So the thing that I learned today was that gobies very low on PFAS. So this is good to hear. So we know about gobies. We know they're huge in Eastern Europe. We know that they are the exact shape of a hot dog, and we know that they're low on PFAS.
But I'm going to say, she said 10,000 compounds, 10,000 compounds, and they could only analyze a certain subset. So gobies relatively low on this certain subset of PFAS may have other PFAS, and definitely have other contaminants. But
yeah, well,
crush that dream.
all of that is true. My dream will never be crushed. Yeah, but that's actually, I mean, that ties into the whole deal. Is it's like we just don't even know what we don't know, right? Yeah. And that's just super duper terrifying.
That's why scientists are cool. Teach Me About the Great Lakes is brought to you by the fine people at Illinois Indiana Sea Grant. We encourage you to check out the cool stuff we do at iiseagrant.org and at ILIN Grant on Facebook, Instagram, the platform formerly known as Twitter, and other social media.
Teach Me About the Great Lakes is produced by Hope Charter's Megan Gunn and Irene Miles. Carolyn Foley is our senior producer. Ethan Chitty is our associate producer and our fixer. The super fun podcast artwork is by Joel Davenport, and the show is edited for at least a few more by the awesome Quinn Rose. We thank her for everything.
If you have a question or comment about the show, please email it to teachmeaboutthegreatLakes@gmail.com or leave a message on our hotline at 765-496-4474 or at ISG. You can also follow the show on the platform formerly known as Twitter at Teach Great Lakes, but like the PFAS in a Lake Michigan salmon, we're a little worried about how toxic it is. Thanks for listening, and keep grading those lakes.